Hey engineering family, for my fluids project today, I'm going to add a little twist and try to see if I can calculate and figure out the differences in flow rates between using a submersible pump underwater inside of a pot and checking out the flow rate coming out of the pump itself and using a 50-foot hose at the end of the pump.
Here I have the scenarios of the pump being inside of the pot in a different water level. The temperature of the water that I'm going to use is 90 degrees Fahrenheit. It's been pretty hot here, so I figured that would have been a good temperature to use. I'm neglecting the head loss, we're neglecting the friction, and we're also neglecting the electric wire, the electric unit part of the wire. Today we're going to experiment these two scenarios and how, with the water being 15 inches inside of the tank, using Bernoulli's equation, we can see that the pressure at the surface is 0 and the velocity is 0, of course. And then moving on to stage 2, the pressure here, because of the depth of the water, we have a P2 and we also have a velocity, of course. And our reference point is here at the bottom of the pump where the water actually flows inside of the pump, so we can neglect that, and that also makes that 0. And next we have the pump head. Our P3 here is 0 because it's exposed to the atmosphere. Outside of the water we have V2, our velocity is 0, and our Z3 is the elevation between our reference point, which is where the water flows inside of the pump, to where it actually leaves the pump. Have pretty much the same between stages 1 through 2, except that our elevation between 1 and 2 is different because of the reference point and the level of the water. Our Z1 changes here, but our Z2 remains 0. And also our pressure does change because the depth of the water does change, so it is more pressurized there. Okay, and then moving to stage 3 here, now we have a pressurized outflow. So we do have a P3 here, and we have a V3, of course, and a Z3 because of the elevation. In the last scenario, we're going to experiment the hose attached and how that outflow changes with stage 3.
Here you can see I have the calculations of the pump inside of the pot with the water being at a depth of 15 inches, and you can see that the velocity here comes out to be 5.8 feet per second. And so we're trying to see and think, will it be stronger with the hose or without the hose?
If the water would stay still, you can see it's at 15 inches. Okay, with our first test, we are going to see how far the water goes down and how long it takes without the hose. Go. So 40 seconds, and we see the water has reached, what is that? A little over 6 inches. Okay, now filling the pot back up with water, and this time we have the hose attached. All right, so for the next part, we got the hose attached, and we are going to see in 40 seconds how far down the water goes. Okay, go. Measuring now our water after that. A little over 11. As you can see, using a base time of 40 seconds, the water in the pot went down a total of 8.5 inches without the hose. But with the hose, it went down at least 3.75 inches. So definitely without the hose, it exerted a lot more pressure than with the hose. Hopefully it gets me across the waters, but yeah, I hope you enjoyed it. Stay blessed, stay safe, stay healthy. Peace, love, and happiness.